Hello everyone, thank you for being here. So what I am presenting today is the conceptual framework of our permissioned blockchain-based technical solution that we are currently developing. And the aim of the solution is to address challenges of contractual time performance management on construction projects. So just to put this piece of work in the wider context of the built environment, so contractual time performance management lies at the intersection between construction project management and construction contract administration at the project level. So just to give you a feel of what we mean by time performance management here, it is not in fact a single process, it is a mechanism that consists of several processes and sub-processes. And in this particular instance here, we have derived these processes and sub-processes from the standard form of contract. Here it is FIDIC Red Book 2017 edition, and this was based on contractual analysis that has been validated by 3 experts from the FIDIC field. I will come back to this figure again in another form after 2 slides to let you know about the contractual related challenge in these processes. As you can see here, the dotted lines, for example, the red and the blue, referring to disconnection among these processes according to the FIDIC model. So here we are presenting the problem, and what is the problem here? The problem is inefficient and ineffective management of contractual time performance on construction projects. At a high level of analysis of literature and industry-driven reports, we have identified two streams of challenges at a high level, as I stated. So these are contractual related challenges, and these contractual related challenges can be classified under the term organized complexity of contracts. On the other hand, the other stream is about management related challenges, and here these challenges can be classified under the term disorganized complexity of management. To further elaborate on the contractual related challenges, this is again these are the processes and sub-processes of FIDIC, the combination of which ideally form the time performance management mechanism. Whatever shown in red here, including the red lines, show the disconnection among these processes. This is again, I am stating based on contractual analysis. Of course, our work is not a critical review of FIDIC at all, because there are other reasons behind the availability of such disconnection in a standard form of contract, and these reasons are beyond the scope of our research. But because we have identified an opportunity to enhance the management of this mechanism on construction projects, that is why we started this research work. Moving on to now the management-related challenges. These are again sourced from the existing literature, and in the paper we have cited all the sources referring to these challenges against these processes here. Here I am showing only 5 processes out of the 7 derived from FIDIC, because the literature does not refer to 2 processes, for example, the time program revision and the mitigation measures. So I have listed here only the 5 processes along with their associated challenges. Now, what is the effect of these challenges? The effect is the poor time performance management, which is the research problem. And the ripple effect, there are a lot of ripple effects according to literature and our observations on construction projects, but the most important one is the financial losses to all involved organizations. Now, of course, earlier scholars have recognized this problem, and in turn, they proposed and developed solutions through the use of digital technologies, including the use of traditional programming, 4D BIM, AI. However, still there are limitations in these studies, and of course these limitations mainly due to limited research scope, and there is one limitation due to the technologies employed themselves. For example, these studies, most of them tend not to take the contractual context into consideration, maybe to generalize their studies. The focus is on a single process, like seeing only, for example, focusing on program prediction or program monitoring or delay analysis alone, and the centralization that comes up due to the limitation of existing technologies. So what we are proposing here is the use of Hyperledger Fabric as a permissioned blockchain in order to connect all these processes and sub-processes together in order to address some or all of these challenges shown earlier, like contractual related challenges and management related challenges. Our solution has two components similar to the earlier presentations, the off-chain side and the on-chain side. On the off-chain side, we have the construction site itself, where construction activities, engineering activities, and other activities take place. And we have, of course, these activities are performed through human elements and software tools implemented on construction projects. So the point here, we are stating that these human elements and existing software tools like Primavera P6 or existing BIM-based tools can be used as oracles to feed data to the on-chain component. Now, the on-chain component consists mainly here, I'm showing only two parts. I'm not elaborating on the other technical details as shown earlier by Sungaha. So here the most important part is the chain code. The chain code here consists of a number of sets of smart contract functions. Each set of smart contract functions reflect a specific process or sub-process from the contractual time performance management as derived from FIDIC. Under each smart contract function, of course, we have a number of parameters. For example, the claims management process shown here includes like 16 smart contract functions. Two functions of these have like over 15 parameters. All these were required, of course, to reflect the contractual provisions, the contractual obligations, time limits, other contractual requirements as much as possible as stipulated in FIDIC in order to like reflect the reality of FIDIC as much as possible, and of course to contribute to the overall research aim that also investigates the codifiability of standard forms of contracts in the field of blockchain. The other component is the ledger, which consists of the world state and the permissioned blockchain as shown earlier by earlier presenters and in the paper itself. Yeah, so moving on, this is now the whole conceptual framework where the off-chain and on-chain are, of course, digitally connected through middleware, like through APIs and databases. So the benefits of this work include that we believe that this would be a proactive approach to managing like time performance on construction projects. We have proposed a set of smart contract functions in line with the FIDIC Red Book 2017. Our solution, like due to the use of Hyperledger Fabric as a permissioned blockchain, of course, chains all the processes and sub-processes in a single distributed digital environment. And of course, it integrates the peers and their respective organizations, enabling them to have a complete status of the time performance at any given time. And the net result is that the control and coordination related obligations will be enhanced in this context. So yeah, so we believe that what I have presented is an example of how we can move from the traditional project governance to more to a blockchain governance on construction projects in line with what Sungaha presented earlier. Yeah, moving on to our next steps, we are in the process of further completing the coding of the remaining smart contract functions and developing the API rules. And of course, we will conduct further contractual and technical evaluation rounds. On that note, I would like to conclude my presentation. Thank you very much for your time. I look forward to your questions.